All right, let's use the distance formula to find a parabola with a focus at 2, 4, and directrix at x equals -2. And you're finding we're using distance formula. What I'm really using is just the Pythagorean theorem. So I know that there is a parabola in here. It's perfectly between these two. So someplace like this. And on that parabola, there is some point up here. We'll just call that some point x, y. And the great thing about parabolas, which really defines them, is that it's always going to be that distance between here to the directrix, any point xy to the directrix, and any point to the focus. These distances are exactly the same. And knowing that, getting this distance and that distance, right, that's a distance formula thing, we're going to derive the equation. So first, let's focus on this distance here. So this distance right here is going to be from here to here. Well, that's y, high, but then we also have to add on or subtract this distance, or 2 more units. So that's going to be a y minus the directrix, which is a negative and negative make a positive. So y plus 2 for that. So we've got first distance here. Now I've got to get my second distance, which is this one. A little bit harder. This is where that distance formula comes in. So I'm going to make a right triangle, because I can't just count how many units. And I'm going to expand the right triangle. Maybe I'll draw it over here a little bit, just so that we can kind of like think about it over on the side. It won't be so messy. Okay, so let's take it over here. And when I take it over here, I think, okay, how tall is it? Well, I need to use A, B, and C. So let's get A. Pythagorean theorem. A is going to be right here, and that is the height of y, but I have to subtract where I'm already at, which is at 4. So this is going to be y minus 4 tall, and then the width is going to be that x, so it's x all along here, but I have to subtract the 2 that's already there, so that's going to be x minus 2. So the actual distance right here, our c, is going to be a squared plus b squared, the square root of that. So a squared plus b squared, which is y minus 4 squared, square root of that, that is the distance. So I'm using that formula. So I'm going to write that all out. I'm going to take this distance here, which is here, and that, and I'm going to set them equal to each other. All right, so I set them equal to each other. Now that's pretty funky, but I've actually done all of the big thinking now. Okay, I've set it up, and now I'm just going to kind of algebraically try to make this look a little easier to see and have more information. So I'm going to square both sides. Okay, if I square both sides, I end up looking like this. Not quite so bad here. And I highlighted this just because I know that it's an upward facing parabola. I want an x squared, so this is fine. I don't mind that. What's making me uncomfortable is all these y's. So, sorry, this is a y squared. So I'm going to expand these two. So I'm going to expand them out, okay? So I multiplied them all out. And when I do that, I notice this. Here and here, these guys, they'll just cancel each other out, right? Which is awesome. So those go away, and now I'm just left with these, and I'm going to do now some algebra manipulation. I'm going to move the y's all together, and I'm going to move the whole numbers to this side, okay? And then I'm going to end up with this. Now this is looking much better. If I divide both sides, everything by 12, I end up with this equation. Now this looks more like the parabola I expect, okay? And it has some information in it for me. It's positive, so I know it's upward facing, right? And the key things are these here. This is your H and your K, which is our vertex. So looking at this, I have this in vertex form, and I can now identify that it is, the vertex is at 2 and 1. So I can go right back here and label that 2 and 1 as my vertex. So I have now used the distance formula to figure out the formula for my parabola.